Okay, so get this. Imagine being able to know exactly where the most valuable resources are hidden.
Like a treasure map.
Exactly.
Hmm.
But we're not just talking about buried gold, right? Think bigger. What if we could pinpoint a deposit of, let's say, helium-3 on the moon?
Now that's a high stakes treasure hunt.
It is. And believe it or not, we're getting closer to that reality thanks to something called predictive analytics.
It's amazing how this technology is changing the game for resource valuation. And not just on Earth, but in space too.
That's what we're diving deep into today, unpacking how predictive analytics works, what it can do, and, what we need to watch out for. But first, just a level set, what exactly are we talking about when we say predictive analytics in the context of, finding and figuring out the worth of these resources?
Well, at its core, predictive analytics is about using what we know historical data, patterns, trends, to forecast what's likely to happen in the future. And when we apply that to resources, it's like having a crystal ball, helping us assess how much of a resource is out there, what's its quality, and ultimately how much it's all worth.
So it's not just about finding stuff. It's about understanding what that stuff is actually worth,
Right.
right? Like, okay, we found this mineral, but can we even sell it? Is there a market for it?
You got it. It considers things like how pure the ore is, the size of the deposit, what's happening in the market right now, even how much it'll cost to actually get the stuff out and bring it to market.
So many moving pieces, like solving a giant multidimensional puzzle. But hold on, where does all the data for this even come from? I mean, are we talking spreadsheets and databases or something more?
Oh, it goes way beyond that. It comes from an incredible variety of sources. Let's start with the geological data. Think core samples drilled from the Earth, geophysical surveys that kind of give us an X-ray vision of what's underground, and even satellite images.
Wait, we're using satellites to find resources. That's amazing.
Oh yeah, those satellites are like our eyes in the sky, helping us identify areas that are mineral rich, all from space.
Hmm.
But remember, we're not just looking at the rocks themselves, right? We need to understand the whole economic side too. That means bringing in market data.
Right, so we need to know what the demand is like, supply and demand, all that.
Exactly. What are the current and past prices for this commodity? Is the demand for it going up or down? And how easy or difficult is it to actually get this resource out of the ground, transported, and all the way to the people who want it?
Sounds like a lot of research goes into this, but wouldn't we also want to, I guess, look back at past projects?
Absolutely. We look at what's worked in the past, what hasn't, how much things cost, and what the environmental impact was. It's all about learning from experience to make smarter decisions.
So we have all this data and pouring in from everywhere, but how do we actually make sense of it? What are the tools and techniques used in this whole predictive analytics process?
Well, there are a few key approaches. One is using good old-fashioned statistical methods like regression analysis. That helps us see the relationship between different factors, like how the quality of the ore changes as you dig deeper.
So if we notice a pattern, like let's say the deeper you dig, the less valuable the ore becomes, we can use that information to predict what we might find even further down.
Precisely. We also use something called time series analysis to track changes in commodity prices and demand over time. That helps us make better predictions about what the market will look like in the future.
So if we see the price of, let's say, lithium steadily increasing, we might predict that a new lithium deposit will be even more valuable down the line.
That's the idea.
Yeah.
But the really exciting stuff happens with machine learning.
Now you're talking. That's where things get really interesting.
Right. Machine learning can tackle all sorts of tasks. For example, in supervised learning, we train a model on existing data, like feeding it information about known ore grades so it learns to predict the grade in new samples.
So it's kind of like, I don't know, training a really smart geologist who can see patterns that we humans might miss.
Exactly. Then there's unsupervised learning, which helps us identify areas that might be resource rich. Think of it like this. The model groups similar data points together. So if we have data on, let's say, the rock formations in different areas, the model can pinpoint the areas that share characteristics with known resource-rich zones.
And then there's reinforcement learning, right, where we're teaching a model to kind of, I guess, mine as efficiently as possible.
Exactly. It's all about optimizing the process. But of course, we're dealing with the real world here, and nothing is ever 100% certain. So how do we factor in those uncertainties? Well, that's where simulation techniques come into play. We use things like Monte Carlo simulations, which are really good for dealing with uncertainty because they run thousands of possible scenarios.
So instead of just getting one answer, we get a whole range of possibilities,
Uh,
along with, like, the likelihood of each one actually happening.
Right, much more realistic. And we also use something called geostatistical modeling that helps us create a detailed 3D model of a deposit, combining all sorts of spatial data to get a better estimate of how big it is and how much it's worth.
So we've got all these amazing tools and techniques. But how are they actually being used in real-world projects? Can you give us some examples?
Of course, in terrestrial mining, Rio Tinto has been a pioneer in using these models to um, get more iron ore out of their existing mines.
So they're basically squeezing every bit of value out of what they already have.
Exactly. Instead of just digging randomly, they're using data to make smarter decisions about where to mine and how to optimize their processes. Another great example is the Gold Corp Challenge, where they used AI to find gold reserves that had been overlooked.
So like a 21st century gold rush, but with algorithms.
Pretty much. They released all their geological data and challenged teams from around the world to find the gold using AI. It was amazing to see what these teams were able to accomplish.
That's incredible. It shows just how powerful this technology can be. But this isn't just about what's happening here on Earth, right? We're talking about space mining, too.
Absolutely. In fact, one of the most exciting frontiers for predictive analytics is space mining. NASA is using it right now with remote sensing data to figure out how much helium-3 is on the moon.
Okay, back up. Helium-3. Why is that so important?
Well, it has the potential to be a game changer for energy. It could be used as fuel for fusion reactors, which would be a clean and incredibly powerful source of energy.
That sounds like something straight out of science fiction.
It does, doesn't it? But the science is real. And then there's the whole idea of asteroid mining, which is getting a lot of attention these days.
Like mining asteroids for precious metals and stuff.
Exactly. Scientists are using predictive analytics to figure out what those asteroids are made of, how much they're worth, and which ones are worth going after.
So we're talking about a potential gold rush. But this time, it's happening in space. It's mind-blowing. But with all this excitement, there had to be some challenges too, right? I mean, nothing's perfect.
You're absolutely right. Every new technology comes with its own set of hurdles. So what are some of the potential, pitfalls we need to watch out for when we're talking about predictive analytics?
Yeah, what could go wrong? What are we missing?
Well, one of the biggest challenges is data quality. Sometimes the data we have is incomplete, inconsistent, or just plain wrong. That makes it really tough to build accurate models. We also have to be aware of measurement errors and variations in how data is collected.
So it's not just about having a lot of data, it's about having good data. Garbage in, garbage out, as they say.
Exactly. And then there's the issue of model complexity. Sometimes these models can get so focused on the data they were trained on that they don't generalize well to new situations. That's called overfitting, and it can lead to some pretty inaccurate predictions.
Like the model is stuck in the past and can't see the future clearly?
That's a good way to put it. So we need to be really careful about how we build and test these models. And of course, we have to consider the computational costs. Running these big simulations and training complex models takes a lot of computing power, which can be expensive.
Right. It's like anything else, you get what you pay for.
Yeah.
So we've talked about the basics of predictive analytics, the data, the techniques, and some real-world examples. But what about the bigger picture? I mean, this tech has the potential to reshape entire industries. Are there, like, ethical or societal implications we need to be thinking about?
Oh, absolutely. You raised some excellent points. But before we jump into that, let's take a closer look at some of the cutting-edge technologies that are pushing the boundaries of what's possible with predictive analytics. We'll come back to those broader implications later on.
Sounds good. I'm always up for exploring the latest and greatest advancements. So what's next? What's on the horizon for predictive analytics?
Before we get into those new technologies, it's worth thinking about how predictive analytics is changing what we even consider a resource to be.
That's interesting. I always thought of a resource as something tangible like, oil in the ground or minerals in a mountain. What else could it be?
You're right, the physical presence of a material is key, but with predictive analytics, we're starting to see resources in a more dynamic way. It's not just about what's there, but also how accessible is it? How much does the market even want it? What technologies are out there to actually get to it and process it?
So something that might be considered a low-value resource today could become super valuable in the future if, let's say, a new extraction method is invented or the demand suddenly skyrockets.
Exactly. Imagine a deposit of rare earth elements that's just too difficult and expensive to extract right now. If someone figures out a cheaper, more efficient way to get to it, or if demand suddenly surges because of, I don't know, some new green tech breakthrough, that deposit could become a gold mine, so to speak.
So we're not just finding what's valuable now, we're trying to predict what's going to be valuable in the future.
Yeah.
It's like we're not just explorers, we're forecasters too.
That's a great way to put it. And this has huge implications for how we think about managing resources, both on Earth and in space.
Can you give us some specific examples of how this is playing out? Let's start with terrestrial mining. What are some of the biggest challenges we're facing, and how is predictive analytics stepping up to the plate?
Well, one of the biggest issues is the declining grade of ores. As we mine the easy to reach high quality stuff, what's left is often lower grade, meaning less concentrated. It makes it harder and more expensive to get what we need.
So how can predictive analytics help with that?
It can help pinpoint areas where those lower grade ores might still be worth mining. Maybe they contain a unique mix of valuable elements, or perhaps there are new processing techniques that make extraction more efficient.
So instead of just walking away from these lower grade deposits, we can use data to figure out how to make them work.
Exactly. We need to get the most out of the resources we have, especially as those easy to reach deposits become scarcer.
What about the environmental side of things? Mining can have a big impact on the environment. How can predictive analytics help us minimize those impacts?
Oh, that's a crucial area where this technology can really shine. We can use models to predict potential environmental problems before they even happen, things like water contamination or disruption of habitats. This lets us design mining projects from the start to reduce those risks as much as possible.
So instead of waiting for something to go wrong and then scrambling to fix it, we can use data to anticipate those problems and prevent them.
Exactly. It's about being proactive, not reactive. We can build in safeguards from the get-go to make sure we're extracting resources in a way that's good for both the economy and the environment.
Okay, that makes sense. Now let's talk about space. You mentioned asteroid mining earlier. Can you walk us through how predictive analytics is being used to, figure out if those asteroids are worth mining?
Sure, it all starts with gathering as much information as we can about those asteroids. Their size, shape, what they're made of, what their orbit is like. We use telescopes, remote sensing instruments, all sorts of cool tech to build up a profile.
So we're basically making a detailed ID card for each asteroid.
Exactly. And once we have that data, we can feed it into predictive models that take all those factors into account. How much of the valuable stuff is there? How hard will it be to get to it? How much will it cost to bring it back to Earth? It's a complicated puzzle, but it helps us prioritize which asteroids are the most promising.
It's like running a virtual asteroid mine to see if it's even worth the investment. What are some of the things we're looking for on those asteroids? What makes them so valuable?
Asteroids are known to have lots of valuable elements, some of which are really rare here on Earth. For example, they often contain high concentrations of platinum group metals.
Those are used in everything from electronics to cars, right?
Yeah.
They're super valuable. But isn't it incredibly expensive to even think about mining stuff from asteroids and bringing it back to Earth?
It would definitely be a big investment, but the payoff could be huge. And we're not just talking about metals either. Asteroids also contain water ice, which can be broken down into hydrogen and oxygen. That's fuel for spacecraft and potentially even breathable air for future space habitats.
Wow, so asteroids would be like giant cosmic gas stations and supply depots for space travelers?
That's the idea. There are even some scientists who think we could use asteroids as building materials for large structures in space, like orbital habitats or even solar power satellites. Imagine building entire cities in space using resources harvested from asteroids.
No, you're just messing with my mind. But seriously, are we really talking about something that could happen, in our lifetime? Is asteroid mining really feasible?
The technology is being developed right now, and with predictive analytics, we're getting a much clearer picture of which asteroids are the best targets and how to actually mine them. It's really just a matter of time.
This is all so exciting. It feels like we're on the verge of a whole new era of space exploration and resource utilization, with predictive analytics leading the way.
It's a thrilling time to be involved in this field, for sure. And the impact of predictive analytics goes way beyond just finding and valuing resources. It's playing a vital role in shaping the future of space exploration, maybe even the colonization of other planets.
Okay, now you've got me hooked. How does predictive analytics fit into that big picture? I mean, space exploration is already so complex and challenging. How can predictive analytics help us overcome those challenges?
Well, think about it this way. If we want to live on the moon or Mars permanently, we need access to local resources. We can't ship everything from Earth. It's just too expensive and logistically difficult.
So we need to learn to live off the land, so to speak,
Yeah, like
become a multiplanetary species that can sustain itself.
exactly. And that's where predictive analytics shines. We can use it to find the best locations for lunar or Martian outposts, spots where there's water ice, building materials, even potential energy sources.
Like finding the best real estate in the solar system.
Exactly. It's not just about finding those resources, though. We also need to know how to extract them responsibly without damaging the environment. We have a chance to do things differently in space, to learn from our mistakes on Earth and create a more sustainable future for humanity.
That's a powerful vision. But are there any downsides or risks we should be aware of as we head out into this new frontier?
Of course. One concern is that the race for resources in space could lead to, well, a new kind of space race. Nations or companies competing for control of valuable asteroids or lunar territory. We need clear rules and regulations to make sure everyone benefits, not just a few powerful players.
Yeah, it would be a shame to repeat the mistakes of the past and turn space into another arena for conflict. What else should we be thinking about?
We also need to be careful about the environmental impact of space exploration. Space might seem vast and empty, but it's still an ecosystem we need to protect.
So we need to set up some ground rules for responsible space mining before it really takes off.
Absolutely. We need to learn from what's happened on Earth and make sure we're not just exporting our problems to another planet. We have a responsibility to be good stewards of space, just like we should be good stewards of Earth.
It sounds like we need a whole new set of ethics for this new space age, a set of rules that recognizes the unique opportunities and challenges of exploring and utilizing space.
Couldn't agree more. We need to carefully consider what we're doing in space and make sure it benefits all of humanity, not just a select few. But before we dive into that discussion, let's switch gears and explore those emerging technologies I mentioned earlier.
Okay, I'm ready to hear about what the future holds for predictive analytics. What new advancements are on the horizon? What's going to help us find, value, and utilize resources in even more amazing ways? We've talked about how predictive analytics is changing how we see resources and how it's helping us find those valuable resources both on Earth and in space. But what's next? What are the cutting-edge technologies pushing predictive analytics even further?
Well, artificial intelligence AI is becoming a major player, especially deep learning models. Think of them as a type of AI that can analyze tons of complex data and find those hidden insights that we humans might miss.
I've heard a lot about deep learning. How is it being used in resource valuation?
Okay, so imagine a deep learning model that's been trained on a huge database of geological data, core samples, surveys, satellite images, you name it. This model can go through all that information and pick out these tiny patterns that suggest valuable deposits. It's like having a super geologist on your team.
So it's helping us find resources that we might not have even known were there.
Exactly. And we're also seeing natural language processing, NLP, being used in resource valuation.
NLP. I thought that was for things like translating languages and building chatbots. What does that have to do with finding and valuing resources?
It's more useful than you might think. Think about all the reports, research papers, and historical data that exist about resource exploration. NLP can analyze all that text, pull out the important information, and feed it right into our predictive models. It's like having an AI research assistant that can go through everything that's ever been written about a certain resource and find those hidden clues.
So it's helping us make better use of the information we already have, but it's kind of buried in all these documents. That's really cool. What else is shaping the future of predictive analytics?
Well, the Internet of Things, IoT, is a game changer. Think about a mine with a network of sensors everywhere, constantly collecting data. Data about the equipment, about the ground conditions, you name it.
So it's like giving the mind a nervous system so it can react to changes in real time.
Exactly. And with edge computing, we can process all that data right there at the source, making predictions and adjustments super fast. It's like the mind has its own little brain making decisions on the fly to keep everything running smoothly.
So we're moving towards smarter, more independent mining operations thanks to IoT and edge computing. Anything else on the tech front that's changing the game?
Blockchain is another one that's starting to make waves in resource valuation.
Blockchain. I know it's used for cryptocurrencies, but how does it apply to finding and valuing resources?
Well, blockchain is all about secure and transparent record keeping. So in the resource world, we can use it to track every step of the process. From the initial exploration data to the final sale, it's all recorded in a way that can't be tampered with.
So it's about building trust in the system, knowing that the information is accurate and hasn't been messed with.
Exactly. And we can even use smart contracts to streamline payments and automate certain parts of the process.
So blockchain can help ensure everyone's getting a fair deal and that those resources are being extracted responsibly. It sounds like these emerging technologies, AI, IoT, blockchain, are really transforming predictive analytics. It's incredible to think about what we might be able to achieve with these tools.
It is an exciting time. But as we develop and use these powerful technologies, we have to remember that they're just tools. It all comes down to how we choose to use them, for better or for worse.
That's a really important point. We need to think carefully about how we use these technologies and make sure they're serving humanity and the planet. We already touched on some of the potential risks, like a new space race and the need to protect the space environment. Are there any other ethical or societal implications we need to be aware of?
Well, one concern is job displacement. As these technologies become more and more sophisticated, they could automate many of the jobs currently done by people in the resource extraction industries. That could lead to job losses, especially in regions that rely heavily on those industries.
That's definitely something we need to be thinking about. How can we address that? How can we make sure these technologies benefit everyone?
We have to invest in education and training programs that will give workers the skills they need for the jobs of the future. And we need to consider policies that support workers who are displaced. Things like in-care support, retraining, and creating new jobs in other sectors.
So we need to be proactive and prepare for those changes, not wait until they happen and then try to react. What other ethical considerations are there?
Another important issue is bias. If the data used to train these models is biased, then the models themselves will be biased. And that could lead to unfair or discriminatory outcomes.
So we need to make sure these technologies are being developed and used in a way that's fair and equitable for everyone.
Exactly. We have to be really careful about the data we use, the algorithms we design, and how we actually use those models. And it's crucial to have open and honest conversations about the potential impact of these technologies involving a wide range of perspectives.
That's a great point. It's not just about the technology itself, it's about how we choose to use it.
Absolutely.
Well, we've covered a lot in this deep dive. From the fundamentals of predictive analytics to these incredible new technologies that are changing the game. We've explored the potential to find and value resources in ways we never could before, and we've also talked about the challenges and ethical issues we need to address.
It's a fascinating and rapidly evolving field. It's clear that predictive analytics is going to continue to shape our relationship with Earth and beyond.
We encourage you to keep learning and exploring this topic. Think about how we can use this knowledge to create a more sustainable and equitable future for all.
Thanks for joining us on this deep dive. Until next time, keep questioning, keep learning, and keep exploring.